Let's get started on Chapter 8, Part 2. In this section, we will discuss routers. In the last section, we discussed switches. The difference between a router and a switch is that whereas the purpose of a switch is to connect workstations and servers to create a single local area network, the purpose of a router is to connect networks to networks. In this diagram, we can see that this switch right here connects all of these computers together to form one local area network. And this switch connects all of these computers together to form another local area network. And the router right in the middle connects all of the local area networks to each other and connects them all to the internet. Here is a diagram that shows two networks which are not connected. So to connect them, you would get a router, and this is called LAN to LAN routing. If your router were to connect to the internet, then that would be called LAN to WAN routing. So here is one diagram, and this is a different diagram, but it makes the same point. You've got the router, which connects the local area networks to the local area networks, that's called LAN to LAN, and the router which connects to the internet, and that is called LAN to WAN. Router hardware. A router is really just a microcomputer with two or more network interface cards in it, and each network interface card connects to a separate network. You could say that the purpose of a router is to connect networks, but you could also say the purpose of a router is to separate networks. So any traffic between these computers on this network on the left is not going to cause any traffic on this network over on the right. Routers can be said to connect networks, but they're also said to separate networks. So the way a router works is this. It receives a packet, it then reads the packet header, and then it forwards the packet or drops the packet. And dropping the packet means it just does nothing with the packet. So if workstation number 2 sends a packet to workstation number 4, that packet might hit the router, but the router's not going to push it through. But if workstation 1.0.0.2 on the left is going to send a packet to workstation 2.0.0.4 on the far right, then the router allows these two computers to communicate. A router forwards packets, but how does it know which way to forward a packet? And the answer is the routing table. The routing table, which is located in RAM of the router, shows which network interface card connects to which network. And of course, this is a super simple diagram here where the router only has 3 network interface cards and there are only 3 networks. So this would be the world's simplest routing table. So a routing forwards packets to the destination computer, but what if there are multiple paths? How does the router know the best path from this computer to this computer? Because there are 2 ways to go, and the answer is, again, the routing table. The routing table shows which network interface card connects to which network, and if there are multiple paths, it shows the shortest path based on hops. So what this routing table shows is that you can get to network 3 through network interface card 2, but it'll take you 4 hops to get there. It's really a shorter path if you use network interface card 3. That will also take you to network 4, but there's only 1 hop. Routing tables can be updated manually or automatically, and that's our job. So to manually update a routing table, here's an example of us using the root add command to add an entry to the routing table. And what this command tells the router is this. It says, in order to reach network number 4, data should be pushed out network interface card 2.0.0 8.1, and it'll take 2 hops to get there. You can manually update routing tables, but if you have a large number of routers, that can be really labor intensive. So we use RIP, the Routing Information Protocol. The Routing Information Protocol automatically updates the routing tables on the routers. Every 30 seconds, it sends a broadcast to every other router, so every other router knows the existence of all the other routers, and it allows the routers to find the best path. The Routing Information Protocol updates routing tables, and it calculates the best path based on hops. To install the Routing Information Protocol, we just right-click on Routing and Remote Access and select New Routing Protocol, and then I select the routing protocol, RIP version 2, followed by OK. And then you can see that the RIP protocol is going to send out a broadcast every 30 seconds to stay in communication with the other routers. RIP automatically updates routing tables and allows routers to use the best path based upon hops. Now, there are other routing protocols as well. There's RIP2, IGR, and EGP. These are all routing protocols which are covered in the Cisco courses. A router can also have what's called an access control list, and that can specify what traffic can and can't go through the router. It can be based upon the IP address of an individual computer or upon network ID. So if I want to block all traffic from network 11, I would add an entry to the access control list that says if this packet is coming from network 11, then deny it. So in summary, the function of a router is to read the packet header, and then it either forwards the packet and drops the packet. The routing table shows the router which way to push the packet, and you can have a statically updated routing table, but really it's more efficient to use dynamic updating of routing tables, and that is what RIP does. Note, DCOM 218 Cisco 2 Router and Switching Essentials covers routing in greater detail. Now let's talk about wireless networking. In wireless networking, computers using wireless network interface cards connect using radio frequency to wireless access points. To connect to a wireless network, assuming that broadcasting is enabled, what you do is just go down to the bottom of the screen and select the little bars and click on the little bars. And what that does is give a list of all of the nearby wireless access points in the area which are broadcasting. So I select the wireless access point that I want to connect to, and now I am connected to that wireless network. Risks associated with wireless networking, including people connecting to your wireless router, meaning unauthorized access, or eavesdropping where other people are listening to your conversation. So what you can do to mitigate those problems is to require a passphrase, which is just another word for a password, and to enable encryption. To configure a wireless router for a passphrase and encryption, under encryption, you select the encryption method, for example, the advanced encryption standard, and then you type in some passphrase. In this example, the passphrase is simply pass 1234, probably a terrible password. So when the user tries to connect to the wireless router, the user is prompted for the passphrase or the pass key. Securing wireless networks requires requiring a password and enable an encryption. And for even greater security, you can disable service set identifier broadcasting, and that way nobody can even see the wireless router in a broadcast list. Another way of securing the wireless router is to allow only specified MAC addresses. As you know, a MAC address is a serial number burned into the network interface card. And what you can do is you can type in all of the MAC addresses of the computers which you want to allow to connect. And that's not so bad if you got 3 or 4 computers, but if you have hundreds of computers, it's just not a very good way to go. Now let's talk about network interface cards, their purpose, types, and installation thereof. A network interface card is a circuit board about the size of your hand, and it plugs into slots in the motherboard, and then the cable from the switch plugs into the network interface card. So the purpose of the network interface card is to give the cable something to plug into. But more specifically, what a network interface card does is it converts a parallel signal to a serial signal. As you know, a serial signal is where one single bit is sent at a time. But with a parallel signal, multiple bits are sent at the same time. 8-bit or 16-bit or 32-bit parallel. The inside of a computer operates at parallel, but communication between computers is serial communication, and thus the purpose of the network interface card is to convert the parallel signal inside the computer to a serial computer which can be sent over the wire. There are different types of PC buses, which is evidenced by the different slots on the motherboard. Here is an old industry standard architecture slot, and here is a PCI slot. And industry standard architecture, nobody uses them anymore, would be an industry standard architecture 8-bit, which was used in the original IBM PC, and industry standard architecture 16-bit, which was used in the original AT. But what everybody's using these days is 32-bit architecture. PCI, Peripheral Component Interfaces, uses a 32-bit bus, and it's a commonly used low-priced network interface card. The PCI Express is really the leading technology because that's when they give us that high bandwidth. And then PCI Express times 16 is even faster, but that's only used in video cards. It's not available in network interface cards. Most of us will be working with either PCI or PCI Express network cards. To install network interface cards, you got 2 steps, the hardware installation and the software installation. And the hardware installation simply means plugging the network interface card to the motherboard and screwing in the grounding screw. And then the software installation simply means the installation of the drivers. And if the operating system automatically detects a network interface card, it can auto detect the drivers and auto load the drivers, and that's great. But they don't call us when the drivers auto install. They call us when the drivers don't auto install. And what we have to do is to manually install the drivers, either from the manufacturer's original DVD, or we can download the drivers from the internet. So if you have a Hewlett-Packard computer and you need to download the drivers, what you would do is go to Hewlett-Packard's website and then type in the model of the computer that you have, followed by Go. This is what we're using. And then we select Download Drivers and Software, and that allows us to download the drivers. Now, I can save that driver to a USB drive if I want to take it to another computer, or I can install it on this computer. If I click on Run, it will then install the network interface card driver on this computer. And then after I've done that, I can verify by going to Device Manager, and under Properties, I can see, yes, for this network interface card, the proper driver has been loaded. Downloading and installing network interface cards is a large part of our job as network technicians. Another type of network interface card I would like to discuss is what they call PIXI. and that stands for pre-boot execution. But before we talk about PXE, let's review what's the definition of booting a computer. And everybody knows what that means. To boot a computer means you turn the computer on, and more specifically, the operating system is pulled off the hard disk and loaded into RAM. That's what we mean by booting the computer, pulling the operating system off the hard disk and loading it into RAM. And usually you do boot from the hard disk, but you can also boot from a DVD, you could boot from a USB drive, or you could do a network boot. And that's what's meant by PXE and is commonly used in conjunction with remote installations. Here's the situation. I have a bunch of computers that are brand new. They have no operating system. I want to install the operating system, but I don't want to carry the DVD around to every single computer. So what I do is I set up a deployment server. The deployment server installs the images, and then the workstation connects to the deployment server, and the operating system is installed over the wire. But here's the problem. If this computer has no operating system at all, it can't boot. And if it can't boot, how can it possibly connect to the deployment server? And the answer is a PXE network interface card. A PXE network interface card has a very simple job. Even though there's no operating system on the workstation, when you fire up a computer with a PXE network interface card, it sends a signal to the deployment server, and the deployment server performs an installation over the wire, and now Windows 10 is installed on this computer. If you look at Microsoft TechNet, you can see to initiate a PXE boot, you press F12 upon boot up. PXE pre-boot execution is where the PC boots from the network, and it's used in conjunction with remote installations. In this section, we've talked about hubs, switches, routers, the routing information protocol, wireless networking and wireless security, and wireless network interface cards. And I would like you to look at the Professor Messer videos, which go into all of these subjects in greater detail. And this concludes Chapter 8. Thank you very much, and have a nice day.